Assalamu alaikum warahmatullahi wabarakatuh and very good morning. We continue the second part of our lecture about industrial and extemporaneous manufacturing of solid dosage forms. So as a continuation, now we reach to the instruments called mills that are commonly used in processing of granules, especially in manufacturing of solid dosage forms. And mill, as we know, is a material, is an instrument used for grinding materials. And grinding means reduction of particle size, right? So mills are used in the pharmaceutical industry for reducing the size of granules to achieve the desired particle size distribution for or before tablet compression. And in the practical, we already used the mill too. After the granulation and with granulation drying process, then we use the mill to reduce the granule size to a uniform size. So that will be suitable for tablet completion, for tablet compression. The main types of mills used for this purpose are Fitz mills. There are ball mills also, and there are jet mills. The choice of the mill depends on the properties of the material being milled, the desired particle size distribution, and the required throughput. You want large amounts very fast, or you are dealing with small amounts. Okay, so number one is Fitz mill, and this is the one that we used in the practical in our dosage form design 2. And this is a type of hammer mills. In the class in general, we call it hammer mills. And you know, hammer is something used for knocking material. So these are commonly used in pharmaceutical industry for reducing the size of granules. They are used for milling of heat sensitive and fibrous materials, any materials, and can be used also especially for heat sensitive and fibrous materials. They are efficient in reducing the size of fibrous materials. They don't generate too much heat during the milling process, so they are suitable for heat sensitive materials, and they can be used also for granules used in the process of tablet production. Okay, so how do they work? They utilize a fixed rotor with blades. So here you have the rotor connected to a motor. Once you switch on the motor, then this rotor will start to rotate. There are blades connected to the rotor, and these blades will hit the granules and they will reduce their size. Okay, so there are blades or knives attached to the rotor. Material will be fed into the chamber. They will fall down to the chamber here, and the rotating blades or knives continuously impact the materials. Impacts means hit. Continuously impact the material, reducing it to the desired particle size. And here around it you have a mesh. So only you can put the mesh size that you want. So only particles that reach to the particle size smaller than the openings of the mesh will pass and will be collected, while larger particles will stay in the chamber and will be hit again and again by the blades till their particle size will be reduced. Okay, so these Fitz mills are good enough. They are often used for precise and controlled size reduction, so they are commonly used in industry. The machine from outside looks like this. So here you will have the chamber and the rotor and the blades. From here will be the feeding of the materials, and this container will collect the reduced size granules. Okay, so here is the collection and here is the feeding. Another type of mills is called ball mills, and this one have so many applications and can even, there are so many published papers even for ball mills that even reduce the particle size to even nano size. Okay, so they can be used for reducing the size even of raw materials. If you want, for example, to reduce the particle size to improve the solution of the raw material. So the ball mills also can be used. They can reduce into micron and even nano size. Okay, these mills the mechanism of grinding depends on bolts. There are metal bolts here in the chamber. So powder will be fed into the chamber. There are feeding here from here. They will go into the chamber. There will be rotation of this chamber. With the rotation, balls will impact or will hit the powder and will keep grinding it and reducing its size. So we keep rotating the mill till the particles are reduced to the size, the desired size. Okay, so they use balls made of stainless steel or ceramic to crush the material being fed into the milling chamber. So here we call it milling chamber. The ball size and the speed of rotation can be adjusted to control the final particle size. Okay, and from this mesh at the end, the powder will be collected, so the finished product can be connected. These are the grinding balls. The last type of mills we talk about, or not the last, before the last, the jet mills. Jet mills they use high-speed stream of compressed air or nitrogen to impact the material being fed into the milling chamber. So you have a milling chamber. From outside looks like this. It contains a circular chamber, and materials will be fed into the chamber. And the force that will cause reduction in particle size is the jet force, the compressed air, that will cause collision between the powder particles and will cause reduction in their size. It will result in a fine powder with narrow particle size distribution. They are commonly used for milling heat sensitive and explosive materials. So if you look here at the cross section, this graph showing, or this diagram showing the design, you have feed nozzle here, you have grind nozzles, you have high velocity gas circulation. Okay, this is the chamber where grinding will occur. So materials will enter, and then under gas pressure they keep circulating, they keep hitting each other, they keep hitting the wall, the chamber itself, the wall. They are accelerated by nozzle jets to high velocity. Okay, and then there will be particle size reduction by collision between particles at the end, and then they can be collected. There is also one type of these mills that work by impaction of the material with blades. So they are a type of hammer mill, also same like Fitz mill, but only the design is different. They call it pin mills because they don't have blades fixed to a rotor, but they have a disc rotating and having pins like this. So there are also pins in the other part. Once you close both of them, the chamber having pins of opposite direction, and they rotate and they keep hitting or impacting the material. So pin mills use pins or blades that rotate at high speed to shear and impact the material being fed into the milling chamber, resulting in a fine powder with narrow particle size distribution. Pen mills are commonly used for milling sticky and fibrous materials. They are more efficient compared to Fitz mills when we deal with sticky and fibrous materials. Okay, this when it comes to reduction of size of powders, but there is another mill also we better discuss with the solid dosage forms, which is colloidal mill, and this one is mainly used for reduction of particle size of suspensions or emulsions. It's not used for dry powder like the previous four types. And from the name colloidal mill, so it is used for preparing colloidal dispersions. So they prepare very fine suspensions in micron size, particles will be in micron size. Colloidal mill is a machine used to disintegrate in the disintegration of solid particles or droplet size of a liquid present in suspension or emulsion. So once you introduce emulsion, the particle size of the globules or the size of globules of emulsion will be reduced. And if you introduce a suspension, it will reduce the particle size of the suspended solids to make them very fine. It works on rotator stator principle here in this shape or this one. You have two parts. One of them is stator. So the stator part doesn't move and the rotator part is the one that rotates. Okay, so there will be two parts, stator and rotator, different designs available. So one will be stable and one will be moving, rotating. So they will grind the material between them. The equipment breaks down materials by forming dispersions of materials in a liquid. The shearing takes place in narrow gap between the static cone and the stator. There will be shearing between these two parts. So this will cause reduction in particle size. Okay, of course there will be friction, and this may cause wear or degrade or these parts with time will depreciate. So to reduce this, the rotor and stator are made from toughened steel or corundum. So they are have high resistance for abrasion. Okay, they have high resistance for abrasion. So the design of the rotor can be different, as we see here, different designs. They're different from machine to another. And in this machine, there is some circulation. Means you can feed here your suspension or emulsion. It will pass through this rotor stator part, then can be circulated again. So it can have several cycles till you reach to the particle size or globule size you want. Then you can control the flow direction using the valve. So once you open the valve for recirculation, it will keep recirculating the fluid. Once you finish, you just open the valve in the direction of collection, then you can collect the fluid, either emulsion or suspension, from here. Okay, this is how it looks like. There are so many designs. So you can see a design like this, you can see a design like that. Okay, so the principle is the same, just here the motor is by the side, and in general the motor will cause the rotor and stator to rotate. Here will be the feeding, and then same principle also, you can recycle, you can pass the suspension or emulsion several times, and you can collect from this outlet. And this is the cross section, how it looks like. There is a rotator above a stator. They will keep rotating. There will be some shear forces. It can reduce the size of particles or globules. Okay. Now we mentioned most of the machines that will be used during the different processes required for tablet or capsule production, which are granulation. And so mixing, granulation, and then reduction of granule size to the required size using the mills. Then the last station should be tablet compression. If capsule will be capsule filling, right? So now we go for tablet compression machines, and their function is to compress the powder or granules into the uniform size, weight, and composition. And this uniform size, weight, and composition is the tablets. Okay? So you can feed them with powders, what we call it direct compression, or you can feed them with granules if we use wet or dry granulation in our production. There are two main types. One is called single punch tablet machine, or we call it single station tablet press or tablet machine. So they call it tablet press because the function is compression of the machine, the compression of the powders or granules. Okay. Single station is having, as you see in the shape here, one mold. The same thing, you have punch and you have die, right? So the die is the part that will have like a space that give the shape of the tablet, will be filled with powder. The punch will compress the powder into tablet, that will be ejected and then it will go to the collection tray, right? If you look at this section, you have a feeder, you put the powder or the granules here, they will fall into the die. There is mechanism to remove any excess powder from the die. Then the punches will hit from top and bottom, will hit the powder, will compress it into tablets. There will be ejection mechanism. Tablet will be ejected, will be removed by a mechanical part, and then will be collected through the tray, the collection tray. Okay. Single station machines, they have only the die is not moving, it is fixed station, and there is only one die, there is only two punches, upper and lower punches. So in one process they produce only one tablet. There is another variation from this one also called double punch tablet machine or tablet press, where the station can produce two tablets at each time. Okay, they have a single punch and die set and generally used for small scale production. Mostly it will be inside the labs. In R&D lab, this is the kind of machine that mostly will be used. So will be used for research and development purpose in general. Okay, but you will not find it in the production line in the factory. The machine is simple in design, easy to operate, but the problem it is slow and cannot produce large quantities. That's why it is not used in production lines. So for production lines, we need a high capacity tablet press. So rotary tablet press is the one that is used, and it contains rotating discs. As you saw in the practical before, you have an upper, lower, and middle disc. And middle discs, the middle disc contains the dies. The upper and lower discs contain the upper and lower punches, right? So this machine have multiple punch and die sets arranged in a rotating turret. They are capable of producing, this is the advantage, producing large quantities of tablets quickly and efficiently, and can be used for both single layer and multi-layer tablets. The one we produce in the practical is just one layer tablet because it is a uniform mixture of granules that compress together to form a uniform tablet, right? Okay. Rotary tablet presses come in various designs. There is single-sided, double-sided, and multi-layer, and can be further classified based on the compression force, maximum tablet diameter, and output capacity. So there are many variations. The mini press is like the one we used in the practical. This one doesn't contain so many punches like in this photo, but the number of punches is limited, is smaller. This one we call it mini press, mini rotary tablet press, or rotary tablet mini press, okay? And as you saw, the mechanism is there will be feeding of powder into the die, and then there will be, this is the feeding unit, there will be feeding here, and then they will pass by. The rolls will press the punches against the powder. There are compression rolls on top and at the bottom. In the mini press tablet machine we used in the practical, there is no pre-compression and compression roll. There's only one roll, if you remember, when we showed you. And then this compression force will cause the powder to be compressed into tablets. After this, if you see the movement of the lower punch will go up again, so it will eject the tablet, and the tablet will be removed by the tablet stripper unit into the outlet or collection tray, right? And then we can collect the tablets. This is how rotary press works. There is a special type of rotary press that can allow the formation of bilayer tablets. Okay, bilayer tablets is a tablet where we compress two different mixes of powder, or two different types of granules. So we have, in this case, we'll have two feeders: feeder for mixture mixture A, and feeder for formula ASA, and feeder for formula B. So it will be able to compress a tablet that contains two layers. There are two different formulas. One is formula A, one is formula B. Okay, so these machines are specifically designed to produce two-layer tablets. They are not available anywhere. Even in market, bilayer tablets are not very common as well. Okay, but there are few tablet formulas that or formulations that is bilayer tablet. They have two separate filling stations, as we said, and can apply different compression forces to each layer, allowing for the production of tablets with different release profiles. This is the good thing. You can include, for example, two ingredients, one ingredient in the upper layer, one ingredient in the lower layer. One of them, one of the two formulas of the two layers can be designed to be released probably immediately. The other one can be designed to be released, say, by sustained release. So in this case, you can have different actions. It may contain one ingredient, but there is some dose in the rapidly releasing layer that will cause rapid release of some dose of the drug, and this dose will produce rapid effect, and then there will be sustained release in the other layer to maintain the effect of the drug for longer duration. So here there will be first layer powder will be fed, will be compressed, and then second layer powder after this will be fed, and then there will be compression, and then there will be ejection of the tablet. Okay, so when we want to choose a tablet press for our manufacturing plant, how do we choose them? Which factors should we should consider for the choice of the machine? So the most important is the manufacturing need, specific needs of the manufacturer, including production capacity, versatility, and coating capabilities. So number one is the capacity, like this machine, how many tablets can be produced per hour. So if you want, for example, massive production, then you may need to choose machines with higher capacity. Versatility also, whether they have different compression ranges, wide range of compression force, can accommodate wide range of different tablet sizes and so on. Okay. Coating may not be possible to do in the same machine. So production capacity, they generally have high. If you want high production capacity, then you go for rotary press, not mini press, for example, and definitely not single punch tablet machine. But if you want to buy a machine for R&D, for example, or for teaching purpose for a school, maybe single punch tablet machine may be enough. Okay. And then versatility, bilayer tablet processes are specifically designed for, like, if they can be produced for different applications. So maybe if you have in mind to produce two-layer tablets, bilayer tablets, then you can buy the machine suitable for them. When it comes to cost, depends also. Then you can buy the more capacity, the high versatility, then the more costly the machine. So probably you can choose the one that is suitable for your needs at the lowest cost possible. You have to consider the cost, and then space requirements. Usually, rotary tablet press will need more space. Okay, this when it comes to industrial preparation. So how about production of tablets in the pharmacy? In pharmacies, especially in Malaysia and many countries, not including US. In US, usually have manufacturing pharmacies sometimes, and they produce batches of medications inside the pharmacy. In our countries, usually we don't have the licensing for this, and we don't have the market for it. In case we need to produce some tablets, usually a simple type of tablets called tablet retirates is produced. So when it comes to extemporaneous preparation of tablets, usually we produce not compressed tablets, but tablet retirates, or we call them molded tablets. These tablets are not hard because they are not compressed like the tablets produced in industry. You have a mold of two pieces, as you see. The mold is made of hard rubber, hard plastic, or maybe made of metal. It is composed of two parts. One part we call it die. Die is the one that have openings. Die portion, this is the upper part, a flat plate with the thickness of tablets to be produced, and it can have a number of circular holes. from 50 to 200. So if you fill it completely, you produce this number of tablets. And there will be the punches portion. So we don't have upper and lower punch here, so no compression. We just have a punch that the function will be just the ejection of the tablet. So there is a lower punch that the function is just to eject the tablets. So this is the lower part containing squat, flat corresponding punches that fit the holes precisely. The size of the punch fits the holes precisely, just enough to enter into the holes. So once you push down the die section, then the tablets will be ejected. Okay. So how do you formulate tablet literates in the pharmacy? Usually the excipients added or the base for these tablets is generally a mixture of finely powdered lactose with or without a portion of powdered sucrose. So mainly you use lactose as a filler. There is no binder, there is no glidant, there is no other, there is no lubricant, because we don't have this kind of compression mechanism. So just we have diluent or filler only lactose, and you may contain some portion of sucrose from 5 to 20%. If the pharmacy is producing needs to produce larger amounts of tablets and they need facility for this, usually they will use single punch tablet machine. Okay, so what you do is you put them on the punches. Punches are not into the holes yet, so the punch will work as a support for the holes, and then you fill with the mixture, you leave it to dry, then you push it down, then the punches will cause the tablets to be ejected, and then you just collect. Okay. Okay, now we talk about the last stage for capsule manufacturing. Capsules usually also produced as by just direct mixing of free-flowing powders. These are direct compression grade powders, and then there will be filling, or there will be a granulation process, same like in tablets, mostly with granulation. Then granules will be produced, reduced into the size required by milling, and then the last stage will be capsule filling machine. Will be the capsule filling process. So capsule filling is done by capsule filling machines. There are two types of capsules, as you know, soft gelatin and hard gelatin capsules. So if we talk about powders, then we're talking about hard gelatin capsules. Okay. So hard gelatin capsules or hard capsules filling machines are usually used to fill hard gelatin capsules with powders, pellets, or granules. If you look at some capsules or open them, you may find powder inside. Some of them may have pellets, like the capsules containing drugs for enteric coated pellets, or pellets in acid-resistant material, and they will only dissolve once they reach to the small intestine, like omeprazole, for example. Just go and look. If you get omeprazole, look at the content of the capsules, you will find pellets. These pellets are manufactured with acid-resistant material, and they will only dissolve and release the drug in the small intestine, not in the stomach. They may have also some granules. There are several types of hard capsules filling machines. Okay, there is manual capsule filling machines, semi-automatic and fully automatic. In pharmacies, for extemporaneous preparations, usually manual capsule filling machines are made. For small-scale production in pharmacies, especially in US, they use semi-automatic capsule filling machines. But in industry, fully automatic capsule filling machines will be used. The manual capsule filling machines, they are small, manually operated. They consist of a base plate, a powder tray, a 2-capsule holding plate. The operator fills the capsule manually using a scoop or spatula. Semi-automatic capsule filling machine, these are larger, partially automated, not fully automated. There will be filling part is the mechanical filling system to fill capsules with a predetermined dose of powder or granules is automated, but the manual part is that the operator places the empty capsules into the machine and removes the filled capsules from the machine manually. Okay, so the Capsule filling part is, and closing them is automated, but putting the capsules and removing them from the machine is uh, manual operation. Okay, fully automated capsule filling machines, nothing will be done manually. You just feed, you fill the feeder with the capsules closed, and then the machine will open them, fill them, close them again, and eject them. You just collect them in a barrel. So these machines are fully automated, can fill hundreds of capsules per minute. They use a variety of mechanisms to sort and orient the empty capsules, fill them with the desired amount of powder or granules, and then eject the filled capsules. There are usually four stages for filling the capsules. Number one is capsule separation, means that we open the capsules. You know, the capsule have two parts, so they are separated from one another and oriented in the correct position for filling. Then filling of the capsule, then the material will be poured or will be put in filled into the capsule. The powder or granules are dispensed into the capsules. Then capsule closing, the two halves of the capsule are pressed together to close the capsule, and then capsule ejection, the filled and closed capsules are ejected from the machine. As you see in the shape, you have two, this capsule is closed, it will be fed into the machine, and then they will be guided to have certain direction, and then there will be, by some force like vacuum here for example, the two parts will be separated, and then the granules or powders will be filled into one part of the capsule, and then the cap will be put, and then if there is any capsule, bad capsule in the middle, will be removed by the machine, can identify them, and then capsules will be locked. There will be a locking mechanism here. After locked, finish already, they are filled, so they will be ejected, and there will be the last part, maybe after ejection of the capsule, will be the cleaning of the mold by vacuum, okay, and then air cleaning needle here, and there's suction port, so this will push air, and then there will be vacuum here to receive this current of air, and then the mold will be clean again, so we'll be ready again to repeat the same process, which is capsules will go in, will be opened, will be filled, and then will be locked, and then will be ejected. Okay. So how about in pharmacy? The manual filling of capsules or extemporaneous preparation of capsules. We used the hand-operated filling machine. They have capacities range from 24 into 300 capsules in one time. There are some steps for operation of this capsule filling machine, or we call it fetal capsule filling machine. So first you put the empty capsules in the loader tray, and this loader tray is placed on the top of filler unit, and then by moving it in same as in the shape here, you open the capsules, and then you get the upper part of the capsule into this loader tray. Okay, so when you get your capsules open, then the next step is to fill them with the powder or granules. So you just pour on the plate, and then you keep spreading it with this piece of paper or plastic, or can use spatula as well. Once all of them are full, then you can just you can use some knocking for packing the capsules. You can add more powder to be sure that they are completely packed with the powder, and then after this, the last part is the closure. Okay, then you get your capsules ready. You can collect them and dispense. If you want to see this process in details and even other processes, I already put for you links to YouTube to videos. You can see the capsule filling in industry by capsule filling machine, And then the manual one here, the link, you can see them. Even tablet press also, I put some links. So after we get tablets as a bulk product or capsules as a bulk product, then we talk about packing machines. Then need to be packed either in bottles or in blister packs. So there will be packaging lines. So you have production lines and you have packaging lines. In the packaging lines, we have the packaging machines, and packs are different packs. There are pouch packaging machines, and there are blister packaging machines. We'll talk about soft gelatin capsules manufacturing as well. Okay. And last thing we talk about probably coating. Coating will come before packaging, of course. So let's talk about coating first. You know, some tablets will be coated tablets. You see some tablets that have certain color. Some tablets, once you swallow, you taste taste of sugar. Some tablets are designed for sustained release, and the part that control the release is the coat. It is coated with polymer to control the release. Okay, so usually film coating can be done just to give color, to protect from moisture. Can be sugar coating to mask the taste. Film coating also can mask the taste. So if the drug has better taste and uncoated tablets, once you swallow, you'll feel a bad taste, then coating will prevent this. And sustained release tablets that there is a polymer that control the release also need to be coated with such polymer. So how coating is being done? Coating is simply done in pans. There is a pan that you will throw the tablets inside the pan. You'll put the tablets inside the pan. And this tube is hot air pipe. This pipe is just for drying. And this pan will keep rotating. We call it coating pan. This one will keep rotating. So rotating means that we are turning the tablets in all the sides so that they will be exposed to the coating material. So how the coating material will be applied? There will be a spray. So there will be another pan containing the coating material suspended or dissolved in a liquid and connected to a pipe. At the end of the pipe there is a spray mechanism. So the man working on the pan will just spray the coating material into inside. So now this coating material is in the form of suspension or in the form of usually solution. So we want the solvent to evaporate. How the solvent will evaporate? The solvent evaporate by the effect of the hot air continuously pumped through this pipe. So the man will be, or the worker will be continually spraying the coating material, and this pan is rotating. So all the sides of the tablets will be exposed to the spray, so that they will have a uniform layer around them of the coating material, and this solvent will be dried by the hot air, so it will leave the coating material around the tablets, and tablets, you can get the tablets dry, not wet. Okay, so they consist of a rotating pan, or we call it rotating drum. We put the tablets inside, the coating solution is sprayed onto the tablets while they are being tumbled in the pan. The coating solution is atomized in fine droplets using a spray system, ensuring uniform coverage of the tablets. The pan coating machines may have additional features such as buffles and air handling systems to enhance the coating process. They may have buffles inside to help the tumbling of the tablet. Okay, so after coating the tablets, if they need coating, if they are the formulation to be coated tablets, or without coating, if they are not supposed to be coated, then there will be packaging machines. The most common is the blister packaging machine, but some may be dispensed in or packed in pouches. These machines used to pack tablets or capsules into into pouches, into stripes known as or strips. So we call it strip packaging machine. Okay, these machines are designed to package individual doses of medicines into strips or pouches, providing a convenient and portable dosage form for patients. So, what is the shape of the pouch? Pouch is like a sack. Pouch is like a sack. So, when we talk about strip, then we have two sides. Both sides are flexible. They are usually made from aluminium. Aluminium may be laminated inside by the by a plastic layer, a plastic film. So the shape will be like this. Usually there will be a ceiling. Okay. So it is made, the packaging material is typically flexible laminated alu film that is heat sealed to form the pouches. But here in each pouch there is only one tablet. So you create pouches. You have two flat films of aluminium. Alu film means aluminium, laminated usually from inside with probably plastic material like PVC. And they will come into two rolls against each other. And then by sealing, you create pouches, means there is cavity inside. And here there is only one tablet or capsule in each pouch. Okay. So this machine is usually composed of feeder, hopper, pouch forming mechanism, filling mechanism, sealing mechanism, and cutting mechanism. Feeder, where the tablets will be fed into the line. Hopper, this holds the medication and dispense it into individual pouches. There will be pouch forming mechanism, which creates individual pouching by sealing together the two layers of laminated alu film. They seal the upper and lower layer. This seal will create the borders between the patches. Okay. Uh, and then the last thing is cutting mechanism, because you have a continuous roll, but you want, for example, strips, each of them, or stripes, each of them containing 10 tablets. So there will be a cutting mechanism to cut the size you want that contain the number of tablets you want. Blister packaging machines work with the same principle. The difference is they are having blisters. You know what is blister? That you have in one side, you have a hard PVC, for example, or plastic polymer that have cavities or wells that there is tablet or capsule in each well, and it is sealed with an thin aluminium sheet usually, right? So these machines, they pack tablets or capsules into blisters known as blister packaging machines. They are designed to package individual doses of medication into blisters. So each blister will have one tablet or one capsule. This is a convenient and portable dosage form for patients. The packaging material used, as we mentioned, you have two types. You have flexible plastic film, which is usually flexible but hard, made from PVC, PVDC. There are different materials that can be used. And they are sealed to aluminium film, thin aluminium film usually, and it will form, you can say pouch or not pouch, but you can say it will form the blister, to form blisters, okay? They typically consist of the same things. You have feeder that will feed the tablets or capsules into the machine. You have a hopper that will direct the medication into individual, we say blisters, into individual blisters. There is a blister forming mechanism because the blister will come flat, as you see here. Let's go directly to the shape. You have a feeder, and we can start with the number one. Where is number one here? Here is number one. So number one, you see this is roll. containing very flat PVC film. This flat PVC film, number one, will be heated to be flexible, and then will pass through a part that will form pockets in it. So before it is flat, as you see in the photo, and then here now we have blisters. These pockets are called blisters. Each one can accommodate one tablet or one capsule. So which shape of blisters, which mold we are going to use to form these blisters? The mold should form blisters that are suitable in size to the tablets or capsules you want to pack, right? After this, it will pass through the feeder and hopper. So each pocket or each blister will take one or capsule or tablet. Then this is the role for the aluminum sheet or aluminum layer. It will be sealed into the PVC blisters. Okay, so now you have it is closed. So after this, the last thing is cutting. So there will be sealing, coding, probably there will be some printing, expiry date, production date, batch number, and after this there will be if required some perforation, trimming, and then cutting. Okay, so you will cut at the end into this 10 is number 10 is the cutting or trimming. So it will be in blisters, depends on your design. For example, each containing 10 tablets. Finish, then then eject. Okay, the reject option here is if there is some problem. This can be like this one. There is failure in the production, then it can be rejected. So the machine also can identify strips with problem, blisters with problem, blister packs with problems, and can reject them. So these will be collected and will be packed into carton boxes at the end. Okay, this is how does it work. So the same concept also for it doesn't matter if you are filling capsules or you are filling tablets. The only difference is the mold shape that will give blister shape that is suitable for the packed capsules or tablets. Okay. Last thing is soft gelatin capsule manufacturing. And this one, I don't know, you can say it capsule filling machine. You can say it is capsule filling machine, but for soft gelatin capsules. In this one, you don't have a capsule that is ready-made. Like in hard gelatin capsules or hard capsules, you get the hard capsule shell. You just open, fill, and close again. But you don't have, there is no such soft gelatin capsule ready-made. So usually it is manufactured, the gelatin capsule is manufactured in the production line itself. So you have two parts or two mechanisms. One is for making soft gelatin sheets, and you have another, so there is feeder for powder, gelatin powder. This powder will be made into sheets, and then the sheets will be sealed, same like the strip packaging principle. They will be formed like pouches in the form of capsules, and then they will be filled with a liquid. So there is another feeder for the filling material, and then it will be sealed and then separated from that sheet. We will see it. So the machines used to make soft gelatin capsules are known as soft gelatin encapsulation machines. They are designed to fill and seal two halves of gelatin shell with a liquid or semi-solid formulation. Soft gelatin encapsulation machines can be designed for both small-scale and large-scale production, can also be customized to accommodate a wide range of formulations, including oils, suspensions, and pastes. They are all can be filled into soft gelatin capsules. So you can, when you want to buy machines, you have to consider some factors like what is the production rate, how many capsules can be produced per hour, size and shape of capsules that can be produced in this machine, and viscosity of the formulations that can be injected into the capsule. Okay. So what is the composition? As I told you, you have gelatin tank or powder. I saw a machine in the factory that produces it from gelatin powder. And then there is a the product material tank. For example, you are making vitamin D soft gelatin capsules, say. So here you have vitamin D dissolved in oil or solvent and will be filled into the capsules. Here the part that will make the capsules, the soft gelatin capsules. So how they are being made? There are two parts. This one is duplicate, one here and one here. So they make two sheets at the same time. And these sheets will come against each other. So there will be some forming mechanism or sealing mechanism that will make like a pouch, will make a soft gelatin capsule closed from all sides except the upper side opposite to this injection wedge. And the injection wedge will inject the material, then the upper part will be sealed. And then you come with the sheet, and there are some capsules already sealed, closed. They are still they're still attached to the sheet, and then they will be separated here in this part and will be collected. Okay, and here after this part, the sheet is going out with empty holes, the place or the space for the gelatin capsules that have been separated. Okay, so it composed of gelatin preparation system, is used to prepare gelatin solution that will be used to make the capsule shells. So there is gelatin powder fed, will be converted into solution that used to make the gelatin capsule shells. The system typically includes a heating tank, mixing tank, and cooling tank. And then solution filling system. This one is used to fill the capsule shells with the liquid or semi-solid formulation that contains the active ingredients. And this system typically includes a dosing pump and a filling nozzle. And there will be capsule sealing system. This system is used to seal the two halves of the gelatin shell from the two sheets that come opposite to each other. So it will form a complete soft gelatin capsule. This system typically includes a sealing drum and a drying chamber. There will be a drying chamber to dry, because once they are hot, they are very soft. And then there will be a drying chamber to remove any moisture from them and then make them dry enough. Cooling system is the last thing, is used to cool the capsules after they have been sealed, ensuring that the gelatin shell remains stable. Okay, so once you cool them, then the mold of the two parts together will be stabilized. Okay, this is how it works. If no links, you can just go to YouTube, just type the name of the machine, and then you can see so many interesting videos. It can show you the mechanism and the parts and how the machine works or runs. Okay, so we reached to almost the end. No more materials to machines. No more machines or instruments to discuss. Just to close with some principles like factors to be considered for the choice of equipment if you want to buy equipment for your plant. So number one, production capacity depends on your need. How much of tablets or capsules or how many kgs I need to mix in the mixer, for example, in one batch. In the granulator, how many kgs of powder mix I need to granulate, and so on. So depends on the production scale in your this production line. In this production line, then you can choose the appropriate capacity, machines with the appropriate capacity. Second thing is GMP compliance, because you can browse some supplier websites and you can see there are some machines just probably to use in other applications, not in pharmaceutical applications. But for pharmaceutical applications, they should comply to GMP requirements. So they should comply with the GMP standards to prevent contamination. The main thing for GMP compliance is the machine is designed in some way that will prevent contamination of the product. Okay, so you have to be sure also, you have to verify whether this machine is GMP compliant or no. Because you can use granulator in food industry, you can use granulator in pharmaceutical industry, you can use granulator in many parts. Mixers can be used even for cement production, can be used for many production in many production processes in different industries. So the manufacturer will produce the same machine probably, but with different standards or that suit the user. They will produce GMP compliant machines for those for pharmaceutical industry. They may produce non-GMP compliant machines for other industries. Okay, so you be sure that your machine is GMP compliant. You have to consider the cost also. You have different suppliers, different costs depend on the source. You may buy instruments from China, from India, from Italy, from UK or Germany. Okay, quality is different, but also the price is different. So I came across factories that, for example, the main dosage form produced in any factory is tablets. Tablets, there is massive production of tablets and much bigger compared to any other dosage form. So when it comes to tablet press, the rotary tablet press, usually they will buy the highest capacity machines, and usually they prefer German suppliers because they have a very durable and what do you call it? They're very durable machines that can work for a long time with little problems. Of course, they are more expensive, but because of the high production capacity they need, and so they will spend for it. Some machines or some production lines that may not be used extensively, they may buy lower cost machines like from Italy or China. Okay, then it may not give problems because it will not be used hardly like the tablets. Okay. Depends also on the process requirements. So select machines to meet the specific requirements of the manufacturing process, such as required mixing time or compression force. You saw already, like we have just a small machine for teaching. So when it comes to the compression force range of the tablet press that we have in our lab, it's not that very high compression force. Okay, but if you work in the same formulation, if you use another machine with high compression force, then it can give you very hard tablets. Quality control also. Ensure that machines used in the process have appropriate quality control mechanisms such as sensors or monitoring system to ensure consistent quality of the final products. What we call it in-process or process parameters. Okay, we call it process parameters monitoring. Okay, so you may have some sensors. For example, you are drying machine. You may have some sensor to give you idea about the moisture content. Mixing machines. There is a new application now of IR sensors, IR machines that can give you signals, and then they will process the signal to calculate for you the mixing efficiency, for example, mixing uniformity. Okay, so we call them in-process controls. But this one is very advanced. It's not commonly used in industry, maybe in very big industries, but not common in normal generic manufacturers. And probably you can do in-process control by just collecting samples from the machine on different time intervals, and then do your quality control tests and check whether you reach the target or no. Okay, so thank you for listening, and any question? Any question?